Hello to all of you. This is Dr. Dhaval Maheta, and today we are going to discuss normality testing of the data. Some characteristics of normal distribution are: one, it's a continuous random variable, it is tested for continuous random variable. Two, it's a bell shaped curve. Three, normal curve extends indefinitely in both the directions, approaching but never touching the horizontal axis. Four, it is a unimodal. Five, in this case, mean is equal to median is equal to mode. It is symmetrical with respect to mean. That is 50% of the data lies on the left side of the mean and 50% of the data lies on the right side of the mean. The total area under the normal curve is equal to 1. So these are some characteristics of normal distribution. But we will have to evaluate with some methods. Now, what is the role of the normality and why is it essential that the normality should be present in my data? Many statistical methods require that the numeric variables we are working should have approximate normal distribution. This means that if I consider the 0 as a mean, and if I take plus or minus 1 standard deviation, so 68% of the data is covered if I take plus or minus 1 standard deviation. If I take plus or minus 2 standard deviation, 95% of the data will be covered. If I take plus or minus 3 standard deviation, 99.7% data should be covered. Now, as we are working on sample, we will be drawing the inferences on the basis of plus or minus 3 sigma. Any data which is beyond this 3 sigma is considered to be an outlier. Now, the test which requires that the data should be normally distributed are t-test, f-test, and regression analysis. It is necessary that the data should be normally distributed. Then only we will be in the position to use parametric test. The parametric test group consists of t-test, ANOVA, and t-test and ANOVA. Now, there are some tools for assessing the normality. Well, it consists of formal methods and informal methods. In informal methods, we are having histogram and box plots, normal quantile plot. And in formal methods, we are having the appropriate test. And the test is, this tests are known as goodness of fit test. So we are having Shapiro-Wilcoxon test, Kolmogorov-Smirnov test, Anderson-Darling test. Depending upon the software, different softwares use different tests. Now, in the test of normality, we frame the null hypothesis that the distribution is normal, and the alternative hypothesis is distribution is not normal. The common test of normality includes Shapiro-Wilcoxon, Kolmogorov-Smirnov, Anderson-Darling, Lillofuss test. Problem, they don't always agree. So let us see how we can carry out this in SPSS. Normally, we take the continuous variable whose normality is to be tested. So we will go in Analyze, Descriptive Statistics, Explore. I'll press the Reset button and I'll transfer the salary here. Click on Statistics. Click on Outliers. Outliers are those observations which are beyond plus or minus 3 sigma. They are considered to be the extreme fluctuations in the data. Continue. Click on Plots. Make sure you click on histograms and normality plots with test. Continue. Now click OK. The first thing which you should see is the mean is $34,419 of the salary. The trimmed mean is 5%. The trimmed mean, that is 5%, if it is trimmed on both the sides, you get $32,455. Ideally, there should not be a significant difference in mean and 5% trimmed mean. If the difference is large, it means that the data is skewed. Okay. The second table which is generated is the extreme values. It will generate the highest and lowest. It means that extreme values on right hand side, extreme values on left hand side. You can see that the case number 29, its salary is 1,35,000. This means that when we consider mean as to be 34,419, and if we compute the limits plus or minus 3 sigma, then this 1,35,000 is beyond the plus or minus 3 sigma. It is an extreme fluctuation in this data, and because of which we may get the skewness in the data. So top 5, because of which the data is skewed, and bottom 5, because of which the curve gets skewed. The first thing which we have to see is the histogram, the informal method. You can see there is a lot of you can say there is a lot of data on left hand side. I want the distribution. Double click on it and click on this bell shaped curve, close, and you will get the curve. Naturally, you can see that data is not normally distributed because it is having the skewness. It is having the skewness. So let me copy this. I'll take it on the Word file, Control V. Now there is one more statistics which is being generated, or one more plot is being generated, and this is a stem and leaf plot. Now what is the logic? How stem and leaf plot is constructed? Let me try to explain this. Suppose we are having a data like this. Just a minute. Say for example, we are having a data 11, 12, 13, 24, 25, 27, 31, 32, 17, and 28. Now we start with the 11. So 1 is a stem, and I'll take another one as leaf. The another data is 12. This one, 12. So the stem is same 1 and my leaf is 2. Again 13. So my stem is 1 and my leaf is 13. So 3. Now talk about 24. So here stem will change 2 and my leaf is 4. Again the data is 25. So stem is 2 and leaf is 5. 27. Stem is 2 and leaf is 7. Now 31. So again the stem has changed, and 31, 32 will be here. Now it is 17. So stem is 1 and the leaf is 7. 28. Stem is 2 and leaf is 18. So this is a way the entire stem and leaf is created. Now what is the relevance of this? Let me try to explain. I will take this data from here. Take it into the Word file. Control V, and I will flip the curve. Yeah, that's perfect. I'll try to decrease the size of this chart, bring this in center. Similarly, I will also do it for this one. To bring it in center. Let me expand this. Okay. Now you see both the charts very carefully. Ideally, the shape of both of them is same. Let me superimpose the curve here. So this is the way a stem and leaf is interpreted. Let's proceed further. Another informal method is normal quantile plot. If your data is normally distributed, then this dotted points will all be lying on the straight line. I again repeat, if your data is normally distributed, then all these dotted points will be on the straight line. Basically, this graph is constructed on the concept of x-axis is observed value and expected normal. So if the observed value matches with the expected normal distribution, so you can see here it is 0 is mean, and these are the deviations. So in that case, all the points should be on the straight line. If they are not, It means that your data is not normally distributed. Let's proceed further. Then we have detrended normal QQ plot. In this case, we interpret in such a way that this is a zero line. Your dotted points should be as nearer to zero line. It should be very nearer to zero line. Moreover, there should not be any pattern in the data. If there is a pattern in the data, it means that the data is not normally distributed. So this is again the informal methods of assessing the normality. The last is the box plot. Now the box plot is developed on the concept. Now let's try to understand how the box plots are constructed. This is this is a median. When I take this line, it is a first quantile. This is a third quantile. So first quantile, second quantile, and third quantile. Now I take the inner fencing, that is the upper inner fencing at either 2 sigma or 3 sigma. Here also the same case, plus or minus 2 sigma or 3 sigma, depending upon the requirement. Any observation which is beyond this line, that is the inner fence, upper inner fence and lower inner fence, is considered to be an outlier. This is known as box and whiskers plot. Similarly, we have also got the output here. So the thick line is median. Now let us take the screenshot of it and try to understand. I'll again go back on the Word file. Now this time I'll remove this one. I'll remove this. So I've copied the box plot here. Again, I'll change the orientation and I'll bring it in the center. Now you can see here, it's the same thing where your median is this. First quantile is this line. Third quantile. Let me write down the things here. So this line is first quantile, second quantile, and third quantile. These are the fencings which have been done either at plus or minus 2 sigma or plus or minus 3 sigma, depending upon the requirement of the researcher. Now, this all are extreme fluctuations in the data. Means that is, this data are beyond plus or minus 3 sigma. The extreme is this case, 29 number observation. Let us see what this observation is. So 29 number observation is that the current salary at present are running in 5 digit, but the 29 number observation is having 1,35,000. This was very well indicated here also, that this is an extreme fluctuations in the data, 1,35,000. So this is considered to be an outlier. Normally, if we can remove 5% of the outliers in our data to get the normality, this can be done. So these are the formal methods in which we can test the normality. These are informal methods in which we can test the normality. Now let's talk about the formal method. So here we are having a test. Let me take this test here on my Word file. Control V. Let me expand this so that it's clearly visible. Okay. So what was our null hypothesis? The null is distribution is normal. And the alternative hypothesis is distribution is not normal. Right? Now, let us try to understand how we will interpret. We should always interpret from Shapiro-Wilcoxon test. Basically, Shapiro-Wilcoxon is used for small sample and we interpret from Shapiro-Wilcoxon. You will have to see the SIG value here, right? So it's a thumb rule. The thumb rule is if the p-value is less than 0.05, we reject null hypothesis. And if p-value is more than 0.05, we fail to reject null hypothesis. So here you can see the p-value, SIG value. The p-value here is less than 0.05. How will you write? So you should write in this way. Let me increase the size of the fonts that it is clearly visible to all of you. I'll select all of them, and that is make it Times New Roman, and I'll make this as 12. So when you're writing any paper, you'll write as the p-value of normality test. I'm talking about the SIG value is 0.00, which is less than 5% level of significance. We reject null hypothesis, which means that what is our null? The null is this one. This is our null hypothesis. Distribution is normal. We make this also as Times New Roman, and this is as 12. Let us keep it 40. Okay, distribution is normal, which means that data is not normally distributed. Now there are some ways in which we can make data normal. Let us see those ways. The normal thing is that we should transform the data. So how we can do this? You are very well aware of computing the new variable. So I'll go in transform, compute variable. I'll request all my viewers to kindly refer my previous videos to understand the flow of this lecture series. I'm trying to transform my data, to bring normality in my data. So a normal transformation which is used is logarithmic transform. Click on all, activate ln from here. ln. Now there is a question mark. Transfer salary inside. So it is a normal custom that whatever operations which you carry out on any variable, you will prefix that thing. So ln salary. Click on type and label. So here you can say log of salary. Continue. Click OK. You can see here that a new variable has been generated, ln salary, which is log of the salary. Now I will check the normality of this data. So what should I do now? Let us go back on Analyze, Descriptive Statistics, Explore, right? Remove salary from here and transfer ln salary inside. Click on OK. Keep the things as it is. Now you can see the first thing is mean 10.35 and the trimmed mean is 5%, trimmed mean is 10.33. Both the means are in reasonable limits, so there is no significant difference. The difference has decreased. Moreover, you can see here that the top values, highest 11.81 and the lowest 9.66, they are also more or less nearer to the mean. So first of all, we'll start assessing the normality with the informal methods. Let us double click here. Let us click here. And you can see here that some amount of normality we have achieved. Some amount of normality we have achieved. But we cannot say anything from informal methods. We will have to check for the formal methods also. Let us proceed further and let us see the stem and leaf. Here also, more or less, we are able to get the same result. If you flip the curve, you will be able to see the same result. Okay, normality. More and more points have shifted towards this dark straight line. So there are more points, dotted points on the dark straight line, and therefore we can say that some amount of normality has been achieved. Detrended, more points are now nearer to 0. Let's see about the box plot. So here, box plot, the outliers have decreased drastically. You can see here, and we are getting the curve shifted towards the upper side. Okay. So these are all informal methods. But let us talk about the test, what the test is saying. So here we will see the SIG value. It is again 0.00, which is less than 0.05. So again, we reject null hypothesis, which means that the data is not normally distributed. What was our null hypothesis? Our null hypothesis is that the distribution is normal. Alternative distribution is not normal. And as what is our thumb rule? The thumb rule is if the p-value is less than 0.05, we reject null hypothesis. And if it is more than 0.05, we fail to reject null hypothesis. So again, we got p-value. This p-value less than 0.05, we again reject null, which means that the data is not normally distributed, which means that we are not in the position to carry out the parametric test. So this was all about normality testing. For more videos on SPSS, kindly subscribe to my channel. You can follow me on LinkedIn and Twitter. Please don't forget to press the like button. You can see my playlist in which I have already uploaded many videos of SPSS.